Hi everyone, have a nice and a good day. So today I'm gonna present to you about my Bachelor Degree Project 1 Bmmu 3764. So my project title is about development of a packaging tray from sugar plum fiber, mechanical properties. Before that, let me introduce to you myself. My name is Abigail and I am from BMMP, Bachelor in Mechanical and Manufacturing Process. Thanks to the panels and also my supervisor and co-supervisor, Kamal bin Musa and Dr. Ridwan bin Jumaidi, as they guide me through this journey for my bachelor project 1. The content that I will present today is first the problem statement, next objective, then scope of the study, literature review, methodologies, preliminary result, reference, and my Gantt chart 1 and 2 for base M1 and base M2. So the problem statement is there are plastic pollutions around this world. About 5 trillions of plastic trash are disposed and found in the water river in the whole world. This is based on God's Wills and Gospel 2019. Isn't it worse? These plastics are non-biodegradable plastic which can make the aquatic habitats die. And next is the agro waste. Agro waste produced by the sugar plum fiber, because sugar plum fiber is a byproduct in the agriculture sector. This is based from Nick Bahari 2021. This is because the byproduct from the sugar plums are then being burned, then it can create pollution. So this will make the pollutions more worse. Next, sugar plum is a resource of a reinforcement in a range of a biomaterial applications, which that it is a bio-based packaging material that can maintain the mechanical and bear the characteristic while being stable. This is based on Kumar 2017. This is the limitations of the thermoplastic starch. As we all know, starch is a natural element which can degradable easily. Unfortunately, it is low in terms of mechanicals and thermal performance. This is from Zoe 2015. So next, we are going to the objective of my project. The objective of my project is to produce biodegradable tray from thermoplastic cassava starch TPCS reinforced with a sugar plum fiber SPF composites. So next, we're gonna investigate the mechanical properties of this biodegradable tray. Then we also want to determine the thermal properties of this biodegradable thermoplastic cassava starch reinforced with SPF. Next, we're gonna move to the scope of study. The scope of my study is we're gonna research about the primary organic material, which is we gonna use in this study is cassava starch, glycerols, beeswax, and sugar plum fiber. Next, we're gonna produce the TPCS reinforced with a sugar plum fiber. So we're gonna create this TPS react with a sugar plum fiber according to the ratio 0 to 50 that we have set. Then we're gonna set it inside the hot press for 1 hour at 155 degrees Celsius. So next we're gonna do is we're gonna test the TPS reinforced with a sugar plum fiber by testing it using a mechanical testings and thermal and other testing. For the mechanical testing, we're gonna test it on a tensile, which we want to see the response on the tension force. Then we're gonna test in a flexural, which we measure the amount of force requirement to bend the beam under a 3-point stress. Then we're gonna see the density, which the amount of mass per unit of volume. So for the thermal and other tests, for the thermal, we're gonna test it using TGA, thermal gravimetric analysis, which is we want to see the changes of the sample weight while heating or cooling at a controlled temperature, with changes being consistently analyzed. Then other testing is FTIR and SEM. FTIR is Fourier transform infrared spectroscopy. FTIR is to determine the chemical structure in the material composite, and SEM is scanning electron microscope, which we want to verify and we want to see how the microstructures, morphologies, and chemical compositions is TPCS reinforced with sugar plum fiber. So next, we're gonna move to the literature review. So as I review the glycerols based on a previous study, I found out that glycerols, if we added to the starch, it will enhance the starch plasticizations. This is from Jumaidi 2017. Moreover, plasticizer is a main production of thermoplastics based composite. So it is related to the water absorptions and provide enthalpy of starch plus starch plasticizer complex. Then it render it permanently wet. So next we're gonna move to my next literature review, which that is cassava starch. Cassava starch is well known everywhere. It is 5th world most largely production of starch crop and the 3rd most extensively eaten food source in tropical regions. So we all know what is cassava. So cassava, based on the research from Bernauji 2009, the content in cassava roots are as mentioned as here: the moisture, the carbohydrate, the protein, the fat, the ash, the crude fiber, the potassium, the phosphorus, the vitamin. So all these are contents in the cassava roots. That Bernauji also make a comparison from cassava starch with other more starch, which that on the table. The cassava starch have large amount of amylose average DP compared to the other starch. So next is about the cassava starch composite from previous study. Here we can see the study about the cassava starch, which we can see it is about the utilizations of cassava starch characteristic, applications, and other more that relate to nowadays products, as we can see all here. So next is also the continuous of the cassava starch composite from previous study. We can see it here where they study about the amylose content of the cassava, the solubility of cassava, the moisture absorptions, the comparison of cassava with other starch, and other more, as we can see here. So next is about the thermoplastic starch cassava, or we call as TPCS. So TPCS is the #1 natural source. The TPCS natural source is including rice, maize, potato, tapioca, and other more. This is from Frost 2010. But unfortunately, it has a low tensile strength and deformations, as well as water resistance, which has limited the potentials of this as a packaging material. This is based from Altaya and Plum 2020. So amylose content in TPCS has affect the structure, thermal, and mechanical properties. TPCS is similar as other polymers in terms of linear branchings, molar mass, glass transitions temperature, plasticizer modifications, melting point, and other more. We're gonna move to the sugar plum fiber. So sugar plum fiber is a vital part of Malaysian flora. We all know that sugar fiber, the main structures of this fiber is cellulose, which it contains 65.5%, which this cellulose is excellent for mechanical qualities. Sugar plums is able to make biopolymer under a appealing features. So next, the biodegradable polymers, which it can be reinforced with a natural fiber to form the biodegradable composite. So here's studies about the physical and mechanical properties for the sugar plum fibers. So sugar plum fibers has a large so as we see here, the water absorptions of sugar plum fiber for the physical properties based on study of Hafizal Safwan's 2017 found out that the value of water absorptions is 161.96 plus minus 34.04%, which means that it has a water absorptions that are larger. The tensile strengths, which study by Atika 2018, found out that the value of tensile strengths for SPF is 15.5 MPa. So this is quite high, the tensile strength. Sugar plum fiber consists of 4 parts, which is ijuk, sugar plum bunch fiber, sugar plum trunk fiber, sugar plum frond fiber. So we can see here, there's studies about the sugar plum fibers according to these 4 types of fibers to see the water absorption percentage. This study is from Sahari 2012 and also Hafizah 2017. So next is, we can see here is SPF, sugar plum fiber, and sugar plum starch composites from various studies. So here we can see that sugar plum fiber has been studied about the packaging applications, the bio-nano composite, hybrid composites, and other more. As a conclusion, since many studies on thermoplastic cassava starch have been conducted, it has been discovered that there's no research has been conducted on the integrations of a sugar plum fibers into thermoplastic cassava starch with beeswax. Let's move on to the methodology of my project. So the methodology of my project, as we can see here, this is my flow chart of this project. First, we're going to choose the raw material, which is beeswax, cassava starch, and glycerols. We mix it with dry mixing to produce TPCS. After we produce TPCS, we mix it, we reinforce it with a sugar plum fiber with ratio 0 to 50. It well and make it as a composite in using a hot press for 1 hour at 155 degrees Celsius. Then after that, we analyze the sample according to the ratio. We test it for mechanical, thermals, and other testing. Then we collect the data to see which ratio of TPCS reinforced with SPF are good. Then we will create the tray, biodegradable tray. Then we're gonna make conclusions, and finally we will end it. So, but due to the pandemic, some works needs to be postponed and will be conducted in my PSM2. So the progress for this semester is I have made the preparations of raw materials, SPF, and also preparations of TPCS. So the preparations of the raw material, as we all can see here, the raw materials, sugar plum fibers, are being cleaned and also grind. So the sugar plum fiber need to be cleaned to remove a small stone, soil. There are some also leaf there, so we need to remove this. Then next, after cleaning process, we can cut the fiber into 0.1 to 0.3 cm. This is to make it easy to be grind. So after grinding, we need to filter it using a small net to remove the dust. We only wanted to take the fiber. So after that, the fiber that we get, we need to put it in an airtight container. Next is preparations of thermoplastic cassava starch, TPCS, which first we're gonna wet the cassava starch, and also we're gonna wet also the glycerol. This wetting ratio is 70% of cassava starch and 30% of glycerol. Mix it. Then finally, after producing the TPCS need to be stored in an airtight container. So for the preliminary results, I expected that for the tensile testings, the ratios of 50% of SPF reacted with TPCS will have a higher value. This is because the reference from Harker 2018 state that if the fiber increase, the tensile testings value also increases. Next, for the fracture test, I expected that TPCS reinforced with a sugar plum fiber ratio 50% will have a higher value of a fracture test. This is from the reference Nozeka 2016 and Elias 2019. For the density, I expected that when the SPF contents increase, which the maximum is 50, the density test will decrease. This is from the previous studies that conducted by Etharaj 2017. Okay, for the SEM, they expected that the higher the fiber inside the react with the TPCS, it will have a strong advantage of the TPCS matrix. This is stated or studied by Ibrahim on 2020. For the FTIR testings, I expected that the intense peaks will be 3,200 to 3,500 cms. This referred to the study from Jumaidin 2017. For the TGA thermogravimetric analysis, I expected that the maximum number of fibers inside the TPCS, the minimal the mass will lose. This is from Ahmad 2011 and Carlson's at 2013 studies. Here are some reference for my project. So next we're gonna move to the Gantt chart. This is my Gantt chart for PSM1. This is my Gantt chart for PSM1, and this is my Gantt chart for PSM2. too. So that's all from me. Thank you and have a nice day.